Dear students, today we are learn about the Maxwell equation. Before we are going to Maxwell equation, first we have to understand what is light. As my previous lecture, I, I said that the light possesses a dual nature, that is a particle nature as well as wave nature. So what is wave nature? The localization of a space is called particle and delocalization of a space is called wave. So what Maxwell contribution to the scientific community is that that the Maxwell merges the two forces, that is electric force and magnetic force. Before that, everybody knows that the universe contain five fundamental forces. One is gravitational force, weak force, strong force, and electric force and magnetic force. But after Maxwell came arrive, and he did four equation which merges the two forces, electric force and magnetic force, and and concluded that there is the electric and magnetic forces are not two types other forces, but it is a one type of force, and one can produce the other and other can produce the another one. That is called a electromagnetic wave. And this light is also called is also an electromagnetic wave. So what is light? Light, when we observe a light or a sunlight, in next slide you can see, in the next slide, this is called electromagnetic spectrum. This is the picture of light. When we see a light, your human eye only observe the small portion which you are seeing in the slide. That is a visible light or a optical light, whose wavelength ranges from 400 nanometer to 700 nanometer. 400 is a violet and 700 nanometer is a wavelength for red light. And when you go for the lower end, you will get you are observing a radio waves, microwaves, infrared. And if you are going to the right hand side of the visible light or in a higher range, means the higher frequency range, you are going for ultraviolet, then X rays, then gamma rays, after that the cosmic rays. So from the radio waves to gamma rays, the wavelength is goes down and the frequency is increasing. So frequency and wavelength has a inverse relation, mu equal to c by lambda. So if you increase the frequency, you will get the minimum wavelength. So this is called the electromagnetic spectrum, or it is a spectrum for light also. So light is an electromagnetic wave. So for that, for explain the behavior of light, Maxwell gave a four equation, that is called, now we are known that equation as a Maxwell four equations. So what are the in next these four equation? In next slide I have shown this. So Maxwell gave a four equation. First is a integration E dot dA is equal to Q upon epsilon naught, and these are the four equation which you are seeing in this slide is called the integral equation. There is also a four differential form of that equation also, which you easily get from the by applying the two theorem, that is a Gauss divergence theorem and a Stokes theorems. So first one is the E dot dA, integral of closed loop of integral of E dot dA. You will get a right hand side Q upon epsilon, that is called a Gauss law of electrostatics. Another law is a Gauss law of magnetostatic or a magnetism, is called integration B dot dA is equal to 0. It also signifies that the B dot integration of B dot dA equal to 0. If you apply here the Gauss divergence theorem, you will get a divergence of B dot del dot B, or divergence of B is equal to 0, means the magnetic monopole doesn't exist. So whenever we are talking about the magnetic field, it's always comes in a loop, means like a north pole or a south pole. But instead of that, the electric field possesses a magnetic monopole, means divergence of E exists. That is, divergence of E is equal to Q upon epsilon naught. Just like a first equation, if you take a Gauss divergence theorem, apply a Gauss divergence theorem in a first equation, you will get del dot divergence of E, or del dot E is equal to Q upon epsilon naught. And third law is a Faraday law of induction, and the third law is the integration E dot dl equal to minus d phi by dt, means the change in the flux of magnetic flux, or the change in the magnetic flux produces an electric field. Is it true for converse? Yes, the fourth equation comes play a role, and it is called a Ampere law, and this is called a integration B dot dl equal to mu 0 I. So if B dot dl is equal to mu 0 I, if we take a here we apply a Stokes theorem, we will get a del cross B is equal to del cross B is equal to A, equal to, sorry, J, that is a charge density, that is a current density. In the next slide, the Gauss law, first law is that E dot dA is equal to Q upon epsilon naught, means in a electric field monopole exists, yani means a single charge exists in the nature, but in magnetic field B dot dA is equal to 0, means there is no such type of magnetic monopole, there is always a two pole, that is one north pole and a south pole. In the third equation, if you change a magnetic field, you induce an electric field, that is Faraday law, and is it the reverse is true? This is defined by fourth equation. So suppose if we are considering a capacitor, and if we make a loop here in a slide, there is a green loop. If you take, if a current is passing through a conductor or a capacitor, so you can calculate a magnetic field B from this Ampere law, integration B dot dl equal to mu 0 I, where I is the total current. But instead of this type of Gaussian surface, if we considered a backside surface like this, if loop encloses the plate of the capacitor, there is a problem. There is no such thing of current between these two space of the capacitor. The second diagram is a front view and third diagram is a side view. So what happens is there, if I is 0, then integration B dot dl is equal to 0. As we know, the Ampere law is independent of the design of the surface. So how we can solve this type of dilemma? So Maxwell gave a solution, and he said that the inside the capacitor there is no current, but there is a change in electric field, because one plate of capacitor is a positive charge and another plate is a negative charge. So there should be a electric field between these two charges, and these electric charge field charges, this electric field continuously changing. So the continuously changing electric field produces a magnetic field, and the idea defined by given by the Maxwell, and Maxwell introduced a equation B dot dl, or modify this equation by mu 0 epsilon naught d phi by E upon dt, where d phi by dt is called id is called displacement current. He called this current is a displacement current. And the fourth equation was modified by the Maxwell, and you will get a integration B dot dl equal to mu 0 I plus mu naught epsilon naught d phi E upon dt, means changing electric field produces a magnetic field. So Maxwell equation of electromagnetism are, there are four equations: E dot d equal to Q upon epsilon naught, integration B dot d equal to 0, integration E dot dl equal to minus d phi by dt, and integration B dot dl equal to mu 0 I plus mu 0 epsilon naught d phi E upon dt. So you can also write a equation for vacuum where no charges are present. You just put a Q equal to 0, you will get these four equations and nothing else. For today, thank you.